The next topic I want to talk about today is advanced validation. I showed you before that there are a couple of constraints in Symfony core. I don't know if any of you checked out the reference yet. I think that's interesting just to look at. So if you go to Symfony.com and open the documentation section with the reference, then you find that under forms and validation you have a validation constraints reference. And here you have a list of all the constraints that are supported by Symfony by default. Not blank, blank, not null, null, true, false. There's a couple of constraints for validating strings, regex, email length. For validating numbers to be in a specific range, and there's comparison constraints equal to, less than, greater than, date constraints, collection constraints. Collection constraints basically check that a value is one of a set of given values. For example, language checks that a string is a valid ICU language identifier, or choice validates that a value is one of the choice values. There's a lot of other stuff like financial and like IBAN, ISBN, card scheme for credit cards, lots of stuff. So in many cases these core constraints are sufficient to validate very basic constraints, but in some cases they are not. And that's what I consider advanced validation. The easiest way to do advanced validation or custom validation of code that is not satisfied by any of the core constraints is just to add the custom validation code to your controller. So in your controller you always have this if form is valid block, right? Where you do some update of the database and stuff like that, redirect in the end. And you can just add your custom validation code inside that block. So Symfony will run the default validation, and if the default validation succeeds, then you add some more validation on top of that, for example. For example, if the price, that's actually wrong. If the price is smaller than 1, it should be string length. Then you add a new error to the price field, which says that the price is too low. So here you can see how you can easily add errors to fields. One drawback here is that this validation code is only run if the form is valid, and otherwise the validation code is not run. But you can also move that code in front of that if statement. It doesn't really matter. The important thing is that you can add any custom errors to any element of the form. All right? So you can add an error to the form directly, or to any of the fields in the form. And errors are simply form error objects with a message and optionally a set of parameters. That's very straightforward, but it's also coupled to the controller. We can move the code somewhere else, for example using the expression constraint. Symfony, I think 2.4 or 2.5, I don't remember, no, 2.3 or 2.4 out of them, introduced a new component that is called expression language. 2.4? Alright. And basically that language is a subset of Twig. If you have Twig conditions, like if, blah, 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 then these conditions are more or less identical to what the expression language does. So it's a very simple string language that you can use to execute expressions. It's very similar to JavaScript, in fact. And you can use the expression constraint to execute custom expressions and create an error if the expression fails. So in that case, in the expression constraint, you always have the variable value available. The value contains the value of whatever you are annotating here. So value would be the value of the price per ton field, and here you check that the value is greater than or equal to 1, and if it is not, the message too low is displayed. With expression constraint, you can do a lot of stuff, because you cannot just access the value of the field that is validated, but you can also access the object that is validated through the variable this. So if you want to compare two different fields, you can say this price per ton bigger than this, I don't know, price per kilogram, I don't know, anything. I will show you later on how that works in practice. Another method, which also allows you to put the validation code in your model instead of the controller, is to implement a custom callback method and annotate it with the callback constraints. By the way, everything that we're doing with annotations here, you can also do via XML or YAML. So if you don't like annotations, you don't have to be, you don't have to worry about that. You can just use XML or YAML or just raw PHP as well if you want. But annotations, I think they're very convenient. They're very clear and simple to use, so I like them. In this case, we're adding a validation method to validate the price to the good class. You can name it anything you want. The important thing is that you have this callback annotation on that. And here you can execute your validation code and add your error in case the validation fails. Now this is looking a little bit different than what we had in the controller before. In the controller you had a simple form add error statement. Here you have some execution context, add path, whatever. It's really, looks much more difficult. The problem is, that we are not using the form component here, but the validator component. So the form component relies on the validator component to do all the validation. You can use the validation component completely independent of the form component. And in the validator component, one way of customizing validation is the the expression constraint, but another way is the callback constraint. And the validator component has an execution context. It's basically an object that is maintained throughout the complete validation, and it is used to collect errors and do stuff like that. So in this case, you have some validation method. You want to add a violation in the validator component that's called a violation, constraint violation, that with the message too low, and the violation should be put at the path. Path in this case is the name of the property, price per ton. And what the validator component does, it executes validation on an object. The result is a list of all the violations, constraint violations, and each violation has a path how that constraint violation was reached. If you, for example, have an object graph with a ship, and the ship has an associated mount point, the mount point has an associated equipment, and the equipment has a field name which is invalid, then the path of the violation would be something like ship, mount point, equipment, name. That's why it's called path. And here you can just extend this path to match the fields in your class. Kind of complicated. What the form component does in the end is map all these violations that were generated by the validator component to the fields in your form. All right? So this is very useful. It's kind of complex, especially if you never used the validator component before. But that's also a very unlimited way, and it's a way that you can use without the form component. For example, if you have a REST API and you want to execute the same validation in the API as in your forms, then you can just add the validation code to your domain model, pass the submitted data to the validator component without creating any form whatsoever. Another very primitive way of validating that is very useful at some times is to use the constraints true and false That is very helpful if you have methods in your domain model that already do some execution logic. For example, if you have this method in your domain model and you want to check that the price is positive, that should be price, I don't know whether it's a typo. And you want to call it method during the validation, then you can just add the annotation true to make sure that the result of this method is true. And if the result of this method is not true, then the message too low will be displayed. The downside of this approach is that the validated component will always map errors to the fields that correspond to the getters. So the validated component strips the get in the beginning and then takes the rest of the getter as field names. For example, get name, then the field name is name. Or is price positive, then the field name is price positive. And if you don't have a price positive field in your form, the form component will not know where to map that field and it will that error, and it will display the error at the very top of your form. Makes sense, right? Because form component doesn't know what to do, right? Let's display it at the very top. But if you want to display this error for the price positive field at some specific field, like the price field, then you can pass the error mapping option to your form builder and map errors from price positive to the field price. So, at the one hand, this true-false constraint is very simple, but at the other hand, you need to do this error mapping, which kind of, yeah, eliminates the positive sides. So, in the next example, we will validate that we will move away from the good class. Instead, we will move to the ship class, like the ship class in the domain model, and we will validate that the crew size is greater than or equal to its mount point capacity. So the idea is that if a ship class, for example, a destroyer has like 5 mount points or turrets or whatever you want to call it, then you need to have at least 5 people operating these things, just as an example. And we want to validate that the crew size is always greater than or equal than this mount point capacity. To do that, we will use each of these 4 methods that I just described. We'll look briefly at the advantages and downsides of each of these methods so that you understand when to use which of these. To start, we can again check out task 5 complete. So the first method of doing custom validation that I showed before was to change the controller. I'll go to the ship class controller. Here we have create action, for example. And here, before the call to form is valid, we will add some custom validation logic. So we'll say, when handle request was called, we already have the updated class available. We can get that updated class. And then, if the form was submitted, we can check that the crew size is bigger than the number of mount points. So if class, we don't have auto-completion here, so let's add it. Get crew size is smaller than the number of mount points. Then we add an error. Crew size too small. We can contract these 2 if statements to 1. So if the form is submitted, because if it's not submitted, of course, we don't want to run the validation, right? And if the crew size is smaller than the mount point capacity, then we're adding this error. So if we take an existing, or if we add a new ship class, just call it test, and now the mount point capacity is, let's say 4, but the crew size is 2, we should have an error now. Indeed, the error is crew size too small. Now, any idea why the error is displayed here and not at the crew size field? Just.
No validation.
Sorry?
No path. Can you return to the code?
Yeah?
Error at. We didn't specify the element where.
Exactly. So we added the error to the form, but instead we can add it to the crew size field. If we do that, reload, we'll see that the error is at the right position. Now, so much for the new ship class. If we take an existing ship class, and again try to have the crew size smaller than the mount point capacity, that's actually succeeding. Because we just added this code to create action, but not update action. And as you see, that's one of the limits that you already have in a controller. You have to duplicate that code in the other controller, or you have to extract it to some method. We could, for example, say we can extract it to validate ship class, or validate custom constraints, for example. And now we can copy this call to update action. Now if we go to again, crew size is 6, mount point capacity is 8. Yeah. It's a typo. Then it's working. But again, we're just refactoring things around in the controller right now, which is fine. But if we want to use the same form in a different controller, or if we want to use the same validation logic independent of the form library, then it's difficult. All right, any questions about that? Okay. I will now take a different way. Instead of adding the validation in the controller, I'll just comment that out and add the validation using the expression constraint. So we will go to the ship class entity, and we will add and assert expression constraint, which validates that this get crew size is greater than or equal to this dot get mount point capacity. I'm using the getters here because the variables are private and you can only use the public interface in the expression constraint. Let's see if that works. Again, this will be 4. That's 2 over here. And if we submit it, we get the error message again, crew size too low. Again, any idea why the error message is displayed at the top of the form and not at the crew size field? Right. And where should I put it? All right. So the answer was that we put the annotation at the class level and not at the property level. That's correct. So if we move that annotation to the crew size property here, then this should be mapped to the crew size field. Probably work. Yes. So here we have it at the crew size property. It's also possible to move the constraint to the crew size getter, because as I told you, the getter is actually used. So here we have get crew size. We'll move the expression here. And it's the same result. That's very useful if you want to add constraints to virtual fields like getters that don't have an underlying property. Before I showed you that example, get price in euros, which is operating on the price property. You could, for example, add a getter and a setter, set price in euros, get price in euros, and then add a validation constraint to the getter, if you like. I will put it back at the crew size property now. And one interesting thing is that as soon as you put it on the property, you can you can replace the call to this get crew size by value. As I told you before, in the expression constraint you have two variables, value and this. And value contains the value of the property, and this contains the object, like the scope object. So it's a little bit shorter now. Still working. The benefit is, since we moved the constraint to the model and not to the controller, it doesn't matter in which form we modify the ship class. So right now that's new ship class, but we also can edit an existing ship class. Here the crew size is 6, mount point capacity 8. And no matter where you modify the model, you always have these validation errors since they are displayed in the model. If you have a REST API, you can also validate an object in your REST API independent of the form library, and this logic will be executed, and an error will be reported if the logic fails. Are there any questions about the expression component, expression constraint? Good question. No, you can't access any of Symfony's services. So the expression constraint really has just the variables this and value. And anything that you can reach via this, for example, this, I don't know, get mount points, get name, something like that would work, of course, as soon as it's reachable from the current object. If it's not reachable from the current object, you can't access it. Then you need to use a different way, as I'll show you. All right. Yes, you can just do an AND, for example. You can also use, I think, yes. The light is green and not red anymore, so I guess that's a good sign. If you want to find out more about the expression language, you can check the documentation in Symfony. If you Google for Symfony expression language, then you will find the documentation for that. So you will see all like the syntax and all the features that you can use in the expression language. And in fact, you can also use the expression language independent of the validation component. Here you see expression language basically is just It's a simple object, and you can evaluate string expressions, and you will receive the result. Or you can compile string expressions. This will return the PHP code to execute that expression, which is very useful if you want to cache them. Yeah, the syntax, there's a dedicated page about the syntax of the expression language. You can look at it if you like. All right. The third example, or this third method I was showing, used a callback constraint. So if we add a custom validation method again to the model that says, for example, validate crew size, then we can annotate that method with the callback constraint. And then this method will always be executed when validation runs. And here we can check if this crew size is smaller than get mount point capacity. And in this case, we can add some error. And in order to add the error, we receive the execution context of the validator in the callback method and call the add violation method. If the crew size is really too low. Let's see what's happening now. So it's the same thing as before. We have the arrow at the top of the form and not at the field. Any ideas how to fix that? Add violation add, that's actually the old API, which is deprecated, as you can see. The new API would be add path. At least I think so. Right. Build violation. Crew size too low. And here you can add some more properties of the violation. You can set which value was invalid. Thank you. You can set different things. The important thing here is add path, where you can say you want to set it at the path crew size, and then finally you call add violation. So that was added in Symfony 2.5. You have this violation builder. Before you had an add violation method with at least 100 parameters, which you could never remember the order of. Like here you see there's really a lot of parameters. And so we changed it for a violation builder, which lets you discover everything in your IDE, and here you can just see which values you can set in the violation. All right, so build violation, add path crew size, add violation. And here it's mapped to the field crew size again. One quite significant benefit of using this complicated API is that you can, for example, customize the violation message. So in the previous examples, you couldn't really add parameters to the exception message or to the violation message, because messages were just static. And here you could say, for example, crew size too low, please set the crew to at least min members. Then you can call set parameter min and say that's this get mount point capacity. And then this min will be written into the min in the message. It's missing this here. And here you can actually specify that the crew should be at least 8 members. So it's much more helpful than the message that we had before. That's one of the benefits that you have when you use this very extensible API here. Any questions about that? Very good question. The question was why we used the parameter here instead of adding the mount point capacity directly in the string. Any ideas? Translation. Very good point.
I think the question was why do you store the brackets here?
Here?
No, below. Line 2009.
That's because of the translator component. The translator component works that way. I don't know why. The translation component basically doesn't force you to use a specific syntax for parameters in the translation message.
So basically string requires.
Yeah. So you could also, if you say in your project you prefer to have that, you can do that. And actually Drupal is, as far as I know, Drupal is using the validation component, and they're doing that because in Drupal they use percent signs as separators for the parameters, and so they just basically map percent signs to these opening and closing braces. All right, any more questions about that? Okay, so I will also show you how to use true and false constraints. So we could add a new function, is crew size high enough? Or is crew size too low, for example? And here we return this crew size, small this 1 point capacity. And then we can add a constraint to this getter. And in this case, we say that, do we need true or false here? We can either use the false constraint here or true constraint. Which would you take?
I think we should use false because we are checking, or we are returning true if it's wrong.
Right, so it's true if it's wrong, so it must be false. This is crew size too low must always return false for a valid form. And again, we can add some message, crew size too low. Check that it's working. Right, and again, it's the same problem. We have the error message at the top of the form. Any idea why? Right. The violation is added to the field crew size too low. The form doesn't know anything about this field. So we have to set the error mapping option and map crew size too low to the field crew size. And again, we have to field at the right position. But here, contrary to the callback constraint, there is no way to insert the expected amount or the expected number, the minimum, into this message. because we can't insert mount point capacity here. It's not possible. So you see, it's very useful if you already have the getter and if you don't need that flexibility, but then it's also limited compared to this more complex but also more powerful way of doing the same thing. So there was a question with this task, what are the benefits and drawbacks of each method? Okay, this one is empty too. Any suggestions? So the first method was to put the validation in the controller to the form code. The second was the expression constraint. The third was the callback constraint with the callback method. And the third was true and false constraints with the is, with a Boolean getter. Any suggestions when you would use what? What's the benefits and drawbacks of putting the code directly in the phone, in the controller?
Benefit is definitely that it's fast done. So
that what?
You have to invest so much time in it.
Yeah.
The drawback is if you have this validation in separate controllers, you have to adjust every unadjustment and have to implement it again and again and again.
Right. So we'll just repeat it for everybody. If you put the validation code in the controller, then it's very quick. You can do it very, very quickly. But if you have multiple controllers that have the same validation code, you have to copy and paste it and maintain it at the same time. Very good. The second was the expression constraint. What's the benefits and drawbacks of that? Anyone?
Well, you can access the other properties from the same form type, plus data object.
Yeah.
And the downside is that when you can pull stuff from other methods from like servers and stuff like this. So basically, you're just limited to what data you have inside of the controller. You can inject some sample or pull some other method.
Right. Very good too. Okay, so I'll just repeat it. With expression constraint, you can do very flexible stuff. You can access all the data in the object using this, but you can't access external services like the Doctrine Entity Manager, for example, and you can't customize the message and customize other things in the constraint violation. Very good. The third way was the callback constraint. With the callback method, what's the benefits and downsides?
Pretty much we get all the flexibility of the control.
Yeah?
Without all the problems.
Without what?
Without all the problems that goes with the controller once it's in one place, you don't have to copy it. It's not like controller based validation of that right.
Alright, do you really have all the flexibility of the controller?
Not really, it depends whether you have access to container, it really depends on the class and so on.
Alright. Exactly. So the callback constraint is very flexible. I'm just repeating it again. You have basically all the flexibility from the controller, method 1, but without the downside that you have to repeat it in various controls. You have the validation code in just one location. But there's still one downside, and that is that you can't access like external services. Especially if you're working in your domain model, then you probably don't have access to Doctrine Entity Manager or any other external service like that. So you can't access that. But otherwise, it's very flexible. What's the downside, apart from not being able to access services? Yeah, I mean, it's a little bit more complicated from API-wise. You have to use this execution context. You have to understand all that stuff first. So, yeah, but as soon as you know how to use it, and if you have code completion with the use statements in your IDE, there's not really much downside to it, except for the services. And the fourth method was the true and false constraint. Benefits, drawbacks?
pretty hard to reach with solve true, false, or with questions. You can provide for what's actually getting happening.
Yeah. What else?
You still cannot access basically everyone same traits method 3.
Yeah. Anything else? Right. Very good point. So just to recollect, you have very much a lot of limitations. You can't access the container, you can't access external services. You have to do the error mapping in your form because it's not mapped to the correct property by default. Are there any benefits as well? It's just drawbacks so far.
It's kind of readable.
Yeah, it's very readable, it's simple. You can also access all the data of the object. You can access everything, you can do dynamic stuff. Right, and it's good if you already have that getter. If the getter is part of your domain language, why not use it? If it's enough. Okay, so we had a lot of different things, but we didn't solve one problem. We still didn't find a way to run validation that is dependent on an external service, right? Like Doctrine Entity Manager. We can't do that in any of these things that we used right now. Except for the controller, actually. The controller, yeah. But there you have duplication again. So I want to present you two more methods, or actually just one, in a form context for now. Forms have so-called event listeners. So during the life cycle of a form, there are a couple of events that you can listen to, and you can execute custom code when these events are fired. For now, it doesn't really matter which events there are. We are just interested in one of them that is called the post-submit event. So as the name says, this is fired when the form was submitted, independent of whether the form was submitted successfully or if it has errors, doesn't matter. And you can add any kind of callable, PHP callable, to the second argument of the add event listener method in the form builder. So the first is the name of the event. You can look at the form events class to see all the events that are available, or the online documentation. And then you pass a callable, for example, a closure. And in this closure you can run any custom code. The argument passed to the closure is of type form event. And event has two interesting getters. One is getForm, which returns the form that is currently being processed, and getData, which contains the data of the form that is currently being processed. Form event also has a setData in case you want to update data. In this case, we can do the same logic as before. We can get the field price, or price per ton, or whatever it is called. We can read the data of that field, and if it is smaller than 0, then we add an error to the price field. So price in this case is that field. And then we add disclosure as post-submit event listener to the complete form. This means every time that the form is submitted, this code is executed, and if the price is too low, then the error is added. So basically that's very much the same thing as the controller code, but without the duplication. Because we just specify the code once in the location where we configure the builder. I will show you how that works. So I will disable this validation message here, constraint again. Now we'll go to ship class type, where we have the configuration of the form. And here we can add validate crew size. Create this custom closure, and add the event listener to form events. Here you see there's a couple of events here. The one we're interested in is post submit. Here we pass the closure. In the closure, as I told you, we receive an event. And in order to get the crew size field, we can access first the form and then the crew size field. Then we can check the data of the crew size field. Maybe we can do that in a few more steps. So crew size would be the data of the crew size field. And mount point capacity would be the data of the mount point field. Now we compare the two. If the crew size is smaller than the mount point capacity, then the crew size field receives an error. Crew size too small, must be at least. And here we can do the same thing as before. Alright, so it's quite simple code-wise. It's the same thing as before. Here we have the event listener to the post submit event, and then we hope that this is actually executed. Let's see if that works. Crew size too small, must be at least min. That doesn't work. That's one more argument. Yeah. Okay. So now we have the validation code in our ship class type. It's again very tightly coupled to the form. So it only works in the form, but not if you have validation without the form. But now you can access all the data in the field and in the form. And you can also access any external service, because you can't just pass external services to your ship class type. All right? And to demonstrate that, I would like to show you another example. In a good controller, there is some validation code to validate that the name of the good is unique. So before showing you the code, I will just show what's happening here. Here we have a good called gold. If we go to that one, try to save it as gold, we have the error message a good with this name already exists. To validate that, we need the doctrine entity manager, because we need to check that whether the name exists in the database, right? So we can't use any of the simple validation methods that I showed you before. We need the entity manager. And here, if you check the good controller, you have the same code, or more or less the same code, both in create action and edit action. And what it's doing is it's selecting the count from the good table, and it's checking the count of rows where the name is equal to the name that was submitted. And if that count is bigger than 0, an error is added to the field name. That's the create action. For the edit action or for the update action, that's very similar, just a little bit different. For the update action, we assume that there is an existing object with that name, exactly one, and that's the object with the same ID. So the query is a little bit different. It's select count from good, where gname is name, the submitted name, and the ID is different than the submitted ID. And that's why if we submit or edit the gold entry, that works because it's the same ID. But if we edit the test entry and edit gold, submit gold, we have an error message. And I'll show you how to move this validation code to the form type in order to remove that duplication, to remove that, or make the controller a little bit slimmer, because right now the controller is very fat and contains a lot of logic. For that, we'll open the good type class. Again, we have the build form methods, and we do the same thing as before. We create a closure, validate uniqueness, which receives a form event. Then we call add event listener with the post submit event and that closure. Now we can basically copy paste the validation code from the good controller over there. So we're creating a query with the entity manager. We don't have the entity manager yet, but we will do that. We create a query, set account from deep/1 game bundle good G, where gname is name and gid is not ID. And here we set the query parameters. So the name parameter would be the value of the name field. So we first need the form. Get form from the event. And here we call form get name get data. Any idea how we can access the good instance? Yeah?
Form get data.
Sorry?
Form get data.
Right? Form get data. As we looked at in the second topic when we were looking at object-based forms, the data of an object-based form is always the object that the form is modifying. So you can do good is form get data. Since the form is the good form, we are in good type here, we will receive the good object when we call form get data. Alright, so here we have the ID, here we have the name, then we execute the query. If the result is bigger than 0, then we add an error message to the name field. So now the only thing that is missing is the entity manager. We need to pass the entity manager to the closure in some way. And in order to receive the entity manager in the closure, we need to have it in the form type in the first place. So we can change the form type and add an entity manager variable. We can inject that variable in the constructor of the type. And here we just have to reassign this EM to EM in order to be able to use it in the closure. Because if we do use this, then we can't access EM as it is a private property of the good type. Okay, now we have the entity manager, we create the query, we check how many objects have the same name, and if the result is bigger than 0, then we have the error. Same thing as in the controller. Now we can remove all the code from the controller and check if this is working. Here's the update action. We removed all the validation code, and we will do the same for the create action. Right, and everything we do now is the same thing as before. We get the good from the form and we persist it, nothing else. All the validation is happening somewhere else. All right, let's try if it works. Call to member function create query on the non-object. Any ideas? Right. We added a new argument in the constructor, apart from the constructor being called constructor. Yeah. Argument 1 passed to construct must be instance of entity manager. So we need to change the service definition and pass the doctrine entity manager to our service. And good type is already configured in services YAML as a service of name deepspace1.form.good of class good type, and this tag is needed in order to make the form library discover this service, because if we add a field with the name deepspace1good, then the form library will know that this is the right service to use for that type. Okay? And now the only thing that's missing is the argument to the constructor, which is called doctrine ORM.entity manager. And the at is needed for Symfony to know that this is not a string, but a service. The quotes are needed in YAML because at has a special meaning. And as soon as you put it in quotes, it's losing that special meaning for YAML. Now we have the error message, a good with this name already exists. Let's see what happens if we submit an existing good. Update. It works. Now let's see what happens if we add a new good. It works too. All right. So here's the code that we used here. In fact, there's one thing that I would improve from a database side. Right now, if you create a new object with your form, then the ID parameter of that query will be null, because when you create a new object, the ID isn't set yet. And then for specific databases, comparing a value or validating that a value is not equal to null might cause weird effects. Or especially if you have some complicated conditions here, it's not recommended to compare with null. So we can make a case distinction if the good ID is equal to null, then we will use a different query that is not comparing the ID. We'll just remove that second part of the query. And otherwise, we can use the query that is actually comparing the ID. We can check again that this works. Let's update our diamonds. Okay. And if we delete them and add them again, I just hit enter twice. Right, but we can also, if we enter gold, then we get an error. Okay? Any questions about validation inform events? Did we look at custom constraints as a service already? Then you have your answer. What's the benefits and drawbacks of what we just did in general? Any suggestions?
There are different kind of events we can listen for.
Sorry?
There are different kind of form events that we can listen for.
Okay, yeah. So there's different kinds of form events that we can use, not just post-submit. But for validation, we will usually always use post-submit. I think. I never found a case where it's different. Any other benefits? When would you do this? Is this just bullshit that you never need? Well, first of all, it's very useful if you have, for example, if you code custom types, form types. If you have, for example, a complex field, like a field that consists of, I don't know, two time inputs, one for the hour, one for the minutes, and a drop down for the time soon. That doesn't exist in Symfony. Let's say you create a custom field type that does exactly that. That lets you input the time with the time zone together. Then you can use this kind of event listener to validate or to run validation code that is specific to the field and independent of some kind of domain model, for example. Because you can't add any new validation, or you can add it, but just as an example, to the date time pass. So that's an example where you could use that. There's also a different way of doing this. First of all, it's interesting to know that you have the post-submit event, and you can do all kinds of things in the post-submit event. So this was more or less a demonstration of using an event to run custom logic. And in Symfony, in fact, validation is done exactly in this way. So the Symfony component adds a post-submit event handler that is triggering the Symfony validator on the form. And you're just using the same logic that is used in Symfony here to do custom stuff. You can also, instead of using an event, use the constraints option of the form. I showed you before, like in the very beginning, we used an array of constraints, like new, not null, stuff like that, right? And now that you know about all these other, like, more dynamic constraints that we have, you can use them here. For example, you can use the callback constraint and validate uniqueness using this callback constraint, and we just move all this logic over here. The difference is now that validate uniqueness is not an event listener anymore, but now it's a validation, a custom validation method. So we don't have the form event, but we have the execution context. Now we would have to rewrite everything to use the execution context. So yeah, whatever. And you have the value actually. Do you want to look at that? Should I just demonstrate it, or who wants to see how it works? Okay. Just one, but anyway. So in the callback, you receive the value and the execution context. The value in this case is the good object, so we can just call it good, because we add the constraint at the form level, at the level of the form, and the value passed to the validator is the data of the form, so the good object. And then we can also add a type hint here. We can check the ID, everything else remains the same. Instead of form get name, get data, we access the name of the good, get name. And here, instead of adding the error to the form, we do context build violation with this error message. Add path name, then add violation. So we have this callback method for the validator that is using the entity manager passed to the good type service, and then we use the callback constraint to run that callback when the form is validated. Now let's hope that this still works. Ah yeah, we have to remove the event listener here. Alright, and it's the same logic, just in a different place. So it's just two ways of doing the same thing. One is using the callback constraint, and one is using an event listener, but both are using a callback with a different API. Because this is the validator API, the other one is the form API. So you have different possibilities as well. And now the very last thing, the last option that you have, if you want to move this code completely out of the form definition code and completely out of the form controller, but you want to use it in your model, is creating a custom constraint. So then instead of doing new callback, you would say new unique name, for example. And unique name would be your custom constraint that you create, where you can access any external service, like we did right here with the entity manager, and do any custom logic independent of the forms, and independent of the controller. So there's a slide for that as well. Basically, when you define a custom constraint, you define the constraint class itself. You always create new constraint objects anytime you define a constraint on some, like on the annotations. Each annotation is a new object. So these objects are very small, very lightweight. And then you have a validator, the unique name validator. This is created just once in your application. It's registered in the service container. It can access any external services that you pass to it, like the entity manager. And in the unique name validator, you have a validation method that executes your custom code. The custom code is basically the same as we had in the callback right now, in the closure. I won't show the code for that. It's not too spectacular. You can check the Symfony validator documentation how to create a custom constraint if you want to learn more about that. Any questions about validation?
Yeah. What is the best way to activate certain validations based on field data?
On what?
Based on field data. For example, to activate one or two validations only if checkbox is checked. Previously I used validation groups And yeah, in set default options method, I use the callback to return validation, different validation groups for depending on the checkbox state. Is there any better way?
Well, it's validation groups. I didn't show them here. Validation groups are a way of executing constraints in a certain order. So you would assign constraints in your model, for example, to different groups, and then you could say that you only want to execute the constraints of one specific group. That's very helpful if you have a multi-step form, for example. And in every step you want to validate a different set of properties, because every step is filling a different part of the object. Validation groups are not that helpful when you have conditional validation, where you say, if this is true, then I want to do that, or want to validate that. For conditional stuff, you always should use, for example, a callback method, or a custom constraint, or anything like that.
I mean, it works this way,
it works. Yeah, sure. It's kind of a hack, because you would have an error message as well for the checkbox, no?
No.
Because you...
It's not required, so...
Okay. So, I'll just show you how you would do that in, for example, using the callback constraint. Here we have the callback method. I will just remove that code to demonstrate how that would work. For example, let's say if, I don't know, I don't have an example right now, but if good something is complete, I don't know, doesn't exist. But let's assume that we want to run some execution only if that method returns true, for example. Then you can use the execution context, that you see also the power of that, to access the validator. Get validator, and we want to get the validator in the same context. I won't say why this is necessary right now. And here we have the Symfony validator object, and then we can execute any other constraints. For example, we can say at path name, we want to validate that good get name is again longer than 2 characters, for example. And you can add more stuff, add path, price per ton, validate that good get price per ton is greater than 0, I don't know. Okay? So you need these at path calls again to tell the validator which field to map the error message on. So here we are validating the name field, then we take the value of the name field and validate it again against one or more constraints. You can pass just one constraint or an array of constraints. And in this way, you can run any kind of, constraints, execute constraints, depending on a specific condition. You can do anything you like. And now maybe an explanation for the in-context call here. We could also do this, but then we would need to do start context. And if we do that, like if we get the validator and call start context, then all the error messages created during the validation here are collected in a different context. So when we could, for example, get the violations here. Violations is validator get violations. And for example, depending if there are no violations, only then we want to add a violation to the original context, for example. I mean, it's brain fog right now, but business logic usually is that complicated. So we get the validator in the same context, in context like the original context, and then we say validator, or we don't even need that. We just say context add violation foobar. I don't know. So we run some constraints And if there is no error, then we have an error, a violation. Like
so basically, you aggregate them and just show one.
right. It's a way to aggregate violations or the presence or absence of errors to. You can also say if there are any violations above, only then we have one single violation in the original context. Right, and that's why you do start context here. You want to, like git stash with your actual violations that you have right now, do something else in a new context, and then throw that away and do something in the original context. While if you do in context, the original context, then all of the violations created here will be added to the original context and will be displayed in the form. No git stash. And that would be a very convenient way to do that.
Yeah, thanks.
Any more questions? So, right. The workshop ends now. We would have one more topic, but there's a very interesting celebrity debate going on right now, which we can't miss. So I thank you very much for being here today. I didn't expect so many people. I'm really excited about that. And I hope you can excuse like the initial struggles that we had in the workshop. I think it turned out to be quite fine. I hope.
Will the slides be available?
Sorry?
Will the slides be available in the
I can send you the slides, yeah. It's possible. You have the projects. One thing I should add in my slide, and I didn't, is that you should vote. You know, the Netgen has this vote website, and they asked me to ask you to vote on my workshop. I actually didn't ever look at that, so let's see what's happening here. All right, summer camp, day 2. All right, and here you have the 2 workshops, the one in the beginning and the one in the end. Please vote. Give me your honest feedback. You can also give me feedback right after. But if you can't tell me that it sucked, but you can tell me online, that's fine. Thanks a lot.